My name's Derek Clarkson. I have actually been to CocoaHeads quite a while ago. I haven't been for a long time. And for those of you who don't know me, which I'm going to assume is basically most people, I've been in the industry for quite a while. I have been doing iOS development since about 2009, 2010. Worked for a lot of enterprise businesses, banks, insurance companies, small companies, so quite a bit in all of that. What I'm going to talk to you about tonight is not that, in a sense. It's related to that. So before everybody goes, oh no, another boring talk. No, what I want to talk to you about is actually quite a bit different. What I want to talk to you about is when you're doing automated regression testing. So it's actually sort of regression testing and automated testing. So people doing manual testing, people doing automated testing, and your options for doing that. Now, who's actually done stuff like this in an app? You know, and they've worked with servers and APIs and all those sorts of things, right? So your options for that sort of thing, and I've seen all of this done, come down to a few basic ones. And the first option that I have actually seen companies do this, when they do their regression testing, they do it against their live production servers, which is great from the point of view that you know the thing's already there, but from a testing point of view, it's not so good because obviously the data's constantly moving. And you've got issues like, well, you know, what you want to test might not be in production yet, your new feature won't be there. So there's issues addressing that. The next option that I've seen people and companies do is they say, okay, well, let's go to QA, let's go to dev, let's use those servers. Again, this is great from a point of view if it's a live server. It's relatively simple to do within your app because you just redirect to a different URL. But it's also got the down points that obviously, again, the data is not reliable. The servers are usually way less reliable in production, and I've seen people pull a dev server in the middle of a regression test and just wipe the whole thing effectively. So it's not good. Third option that people go for, and in a lot of cases this is actually the best option when you're testing, is that you inject mocks into your app. Okay, so you build up a suite of known responses to known requests and a little bit of software, and you stick it into your app. The good point about this is it's fast, and it's absolutely reliable. You know exactly what you're going to get. And nobody can mess with you when you're doing it. But down points, obviously, you've got to create all these mocks. You've got to work out all your responses, all your APIs, and all the rest of it. And there's also the situation can arise where if you're dealing with an old code base in particular, or perhaps one that's, well, let's just say not well written, injection can be a real problem. It can be really hard to hack into some code. So the fourth option, and this is really what I'm talking about tonight, is using a local mock server. So what we're doing is we're running up a local mock server alongside our app and redirecting our app to the server. The advantages of that, obviously, is again like using QA and dev, you're just redirecting a URL, you're not actually changing your networking in your app at all. The perhaps disadvantage, if you want, is like injection. You've got to know all your mocks, you've got to know all your responses and all those sorts of things. So everything has its good and bad. But what I want to talk to you about tonight is this last option. And I'm talking about it because I've done a lot of it over the years, and particularly working for decent-sized apps with large server backends. We've had to build mock servers to simulate those backends for testing, for debugging, for all sorts of reasons. And in doing all of that, I came up with basically a set of criteria as to what we typically want. The first thing is that obviously we want such a server to be really easy to set up. You don't have to spend hours configuring obscure JSON files or whatever. The second thing is you want your server to be able to start up in a predefined state. Now this comes down to when you're doing CI, because in CI you've got a regression suite. You don't want it to be doing hours and hours and hours of running UI tests. You want it to be as quick as you can. One of the tricks to that is to be able to start from a predefined state. So If I want to test out a payment system for a cart, I want to be able to start my server with a cart already loaded, with a user already there. I don't want to have to wander around the app doing that as part of my test. Next one, predictable. Well, yeah, okay, we want predictable responses. That's a given. We want to be free from interference. Now, there's sort of several levels of interference with things. Obviously, there's external interference where somebody yanks a server out from underneath you, but there's also interference within your test suite. We don't want one test to be interfering with another. And preferably, we want to be able to run tests in parallel because Xcode supports that. So every test needs to be absolutely repeatable, randomly, parallel, without any interference from any other test. The last one is that we want to, I think this is last, I haven't got a preview coming, light and fast. Now, again, this comes down to the servers themselves. Whether it's your injecting mocks or whether you're using a server like I'm talking about, again, you don't want something that's going to take an hour to compile and then 20 minutes to get up before it's in a usable state. So it has to be quick. Excuse me. All right. Now, if you've got all that, as developers, you get a couple of advantages. First thing is that you can use your mock servers to simulate APIs that don't exist. And I've done this on projects when our iOS teams and our Android teams were actually developing ahead of the server teams. So we could use mock servers to simulate the APIs as we thought they were going to be, and then work with that. The other one is debugging and testing, primarily because there sometimes arises a situation where you've got some obscure bug report or some weird piece of data that somebody's created on the production server or something like that, and you want to debug it. Using a mock server lets you quickly and easily do that sort of stuff rather than trying to go to a dev server and figure out how the hell did they get into that position. All right. About a month ago, give or take a bit, I found myself with a little bit of time on my hands, and having built so many of these things for clients, all the ones that I had built for various companies were all fully customized to that company's needs and the developer's needs at that company. So one of the things I wanted to do was to say, okay, I want to take that experience and I want to build something that anybody can use. And so I did have a look around. I went and looked at what was on GitHub and various other lists of mock servers on the web. And I went looking for a bunch of criteria. I went for something obviously fast to start. I went looking for parallel friendly for Xcode. Again, has to be run from Xcode, so let's have multiple. Common languages. I didn't want any obscure languages or anything that people would have to learn or shift their head too much when they wanted to use it. So something that we all know. Easy to configure, obviously. RESTful, again, most APIs that I've dealt with are REST-like APIs, so it has to support that. It's pretty much standard. I popped in GraphQL in there because in the last sort of month, I've had a lot of people talk about it. So I went looking for it. A local process. Some of these mocks offerings that are out there at the moment in the industry, particularly the more commercial ones, tend to be websites. So I could configure a CI run with tests, but I've got to talk to a website to actually get my mocks. So I wanted something that, again, was local because I wanted to run multiple and quick. Request analysis. This is something that I found really useful in building these servers because time and time again, on a server point of view, you get a request from an app and you go, oh, it's got a payload. Right, okay, I need to understand that as JSON, or I need to understand that as a form or whatever it is. So I wanted something that would have some smarts and actually do some of that grunt work for me so I wouldn't have to go around deserializing things all the time. Xcode, obviously. I threw in command line. I've had a lot of time where we've been working alongside an Android team, and so we wanted to have a mock server that we could, in a sense, share. So something that can run from an Xcode UI test and something that can run from the command line for the Android guys or whoever would be great. Response templating, we often do it. Some of the simplest offerings out there just go, here's a URL, here's a piece of JSON, that's what you're going to return. That's the simplest kind of response that you can get. But sometimes you want it to be a little smarter. Like if you're simulating a cart, you might want to have a response where you go, well, here's a piece of JSON. I want to inject some other pieces of JSON to simulate the cart dynamically. Okay, you can assemble it from different files. You can assemble it from objects that you're going to serialize. You can assemble it from bits of strings, whatever. And file serving. Again, this comes down to what people want in apps. A number of apps for example, they use web views. Those web views are often looking for graphics, for bits of JSON and stuff like that. So we want a server we can redirect to. We can have a directory full of all this stuff on known paths, and it will just serve the files like a normal file server. So it can do that, a mix. So I've got a feeling that's the last one on this slide. I looked and looked and looked, and I've actually been looking probably for a couple of years for something like this rather than having to write custom ones. And I never found one that really satisfied all of this criteria. Particularly the parallel friendly was one that I was always looking for and never found. So, as I said, about a month ago, I said, okay, I'm going to sit down and take all my knowledge and see if I can build something. So I built Voodoo. Now, it was up until a week ago, admittedly, as on the intro, it's called Simulacra. That was kind of my working title. I felt Voodoo was better for a number of reasons, but I called it Voodoo. What does this mock server do? Well, obviously it's fast to build and start. This is an SPM project. I can fire up Docker on this machine. Now this is your standard, well, I'll call it standard M1 Pro 10 core. Run Docker up in it. If I git clone Voodoo and then do a Swift build from the command line, it takes it just over a minute to check out all its dependencies and fully build it. Now that is good from a CI point of view because you obviously don't want your mock server to be absorbing too much time. To start it, even from a command line, is actually about as fast as you can hit the enter key. Startup is lightning fast. This is built around very quick code. Parallel testing, what I did was I said, okay, I'm not going to get you to tell me, I'm going to get you to give me a port range. So this server, by default, starts looking from 8080 to 8090. And what it does when it starts up, it says, okay, I'm just going to go through those ports, and the first one I find that nothing is on, I'm going to grab it, and that's the one I'm going to run on. And then you, in your test, you say, what port are you on? Right, we're in business. So that means, basically, when you're parallel testing, the first one gets 8080, the second one gets 8081, the next one gets 8082, and then we keep going round as tests start and stop and carry on. You can give it any port range you like. XCTest, obviously there's a full Swift API there to run it from XCTest. Everyone else is basically shell. The simplest thing it seemed to me was to use YAML as a configuration option. So you can create these tiny little YAML files that are sometimes as little as like 3 or 4 lines that say, when I see this API, I'm going to give it that response. Okay, and these files are composable in that you can have a file with just one response in it. You can have a file with a list of responses in it. Files can refer to each other, so you can have all different sorts of responses in one, and then create like these sort of files that say that and that and that and that is this scenario, and that and that and that and that is this other scenario, and things like that. So JavaScript is for dynamic. So this is a situation where you say, I want to look at this request that's coming in, and I might chuck back a bad request, or I might chuck it back an okay, depending on whatever my decision-making process is. Swift has the same thing. You can give it a single response and say okay, or you can use a closure, and it will let you decide on what sort of response you want to give. RESTful and GraphQL ready? Yep, good. Of course, the GraphQL, I will say, is very new, so I have not used GraphQL myself, so I'm still learning, and I'm still working on understanding how people use it, so that in part of the implementation will probably add more features to as time goes on. The request analysis part that I talked about earlier, there's a whole bunch of things that you can look at in a request that's coming in. For example, in a RESTful path where you have a lot of stuff with slashes and different parts of components of path, you can tag parts of that and say, grab that piece out of the path and stick it in a variable. And it will give you back a dictionary of all those things that you've pulled out of that path. it'll break up your query fields and automatically give them to you as a dictionary. You can say, I want the body as a JSON, and it'll go, right, I'll deserialize it for you and hand it to you. So all that sort of stuff that you would boilerplate out yourself half the time, I've tried to do it, say, these are the things that I want to do all the time, so let's just build it in. Fixed and dynamic responses. I kind of talked about that in a sense. Fixed is really simply where you just go, this is a URL I got, say OK, or say, here's a JSON file to return as a response or something like that. Dynamic ones are the closures and the JavaScript functions, and that's literally where you say the closure and the function get handed the request, they can look at it, they can say, oh, you know, he's asking for this or he's asking for that, I'm going to give him a bad request, I'm going to give him a JSON file, I'm going to give him a redirect, and, you know, whatever you want. It gives you that ability to make this sort of simple mock server that smart enough to be able to simulate what is going on your real servers, but not ridiculously smart. There's a balance act there. File serving, yes, we do that. You can return JSON, YAML, text, binaries, static ones that you've predefined, ones that you assemble out of stuff, it all there. And for templating, for assembling those responses, I've chosen a Mustache engine, which most people, I think, are fairly familiar with. They've all seen the double curly brackets. Mustache, if you've never gone into it any further than that, yes, you can inject values, but it can also build up data iterating over arrays. It's got all that functionality. It can refer to other files and just sort of mash them all together, so you can have parts of a response sitting in different files. So it does all that sort of thing. All right. As I said, Voodoo's a new name. And I was tossing around a couple of different names in Slack channels when I was sort of considering the renaming them. I wanted something that flowed a bit nicer. So the question was, why Voodoo? As somebody put to me, when you've got code like this, a simple test, the one thing that every developer really wants to write is this. Simple. And for me, that was it. That's the name. So I'm going to jump out now.
So we might pause there,
yep.
Dirk, just so we can grab some pizza.
Sure.
If you're about to go to demo.
Yep. Pizza.
Pizza, let's go.
So what I'm going to do is, it's obviously, you know, I'm not going to run big regression suites or anything like that. What I'll do is I'll just basically show you through some of the code. And in this case, it's just a little iOS demo app that I just started building over the weekend, just to sort of like say, well, let's actually see how this thing integrates, and we'll work from there. So I'm going to assume everybody's has run UI tests at some times, or has run sort of UI tests at some times, or maybe experimented with them. But typically, what I've done, or what we've found in almost every single project where we've needed a regression suite like this, is we end up writing an abstract parent test case, which runs up our servers and does all that sort of business stuff that just every UI test runs. So now I'm hoping everybody can read that quite comfortably. I apologise if you can't. Is everybody okay with that? Yep, good, okay. People in the back, yep. All right, so if you're using Voodoo for something like this, obviously you want to import some Voodoo, some magic. And then typically in the setup pause, you would launch the server. Sorry, I'm actually in the wrong file. My bad. Sorry. There we go. That's what I'm talking about. Abstract UI test case. This is the parent of all our test suites and the regression suite. So we would obviously do things like we would have a reference to the app in there because you need it to be able to talk to the app. And we would have a reference to the Voodoo server in there. There's stuff in here for, you know, configuring the launch arguments. Now, this is something done almost every single time. The best and simplest way to actually be able to tell an app to talk to a different server is simply just to pass it a launch argument. So in this case, I pass the launch argument as server, and I just ask my Voodoo server for a URL and just hand it straight across. Inside the app startup, there is a bit of code that goes, oh, okay, I'm going to look for an argument. If there is, great, I'll grab that server and that's the one I'll use. So it's dead simple to write. There's a tear down here, and this is actually important not just from Voodoo, but for anything like this. For those of you who don't know, when test suites run, Xcode actually keeps all of them alive right until the end of the test suite. And for every test in your test suite, so even though they're all in one file, it actually creates a new instance. So if you don't deallocate Voodoo or any other server like this, you will find you'll rapidly run out of ports. So yeah, that's one of the things that's just unavoidable. You need to shut it down. In this case, you just deallocate it. It's done.
Tear down is a standard function.
Sorry?
Tear down is a standard function. You
Yes.
just override it.
Yep.
Why can't you do it so?
Sorry, can we leave questions until the end, please?
Yep. We'll come back to that. Okay. Then we just typically, again, I just create a couple of different functions to support. One to launch the server, to launch Voodoo, set it up with any parameters and stuff that it may need. You'll notice here that we're giving it some endpoints. Now, endpoints is basically where you say, this is the URL you're looking for, this is the response I want you to give. It's a fairly simple data structure. Okay, and I've done it through a builder, so we can make it fairly nice. And the other function that we typically have is to launch your actual app. So when we're using that in a simple UI test, it just looks like this. We just basically, in our setup for our test, we're saying launch the server, and we're giving it a bunch of endpoints that I've pre-configured, and then we run our test pretty much as we normally would. Okay, so launch server. Always launch a server like this first, because otherwise your app might try and go and talk to it before it's actually launched. So pretty obvious. The endpoints we would often, again, there's a bazillion ways of doing this, and almost every client likes to do it completely differently and completely contrary to every other client. That's the way customers are. For simplest sake in here, I've got an enum. I'm just going to set up a bunch of statics and create the endpoints that Voodoo uses. Now, here's the first one. It's a config, and it just basically says it's a HTTP endpoint. It's looking for a GET. It's looking for that path. And when you see it, respond with an OK and a JSON body built from that data. So that's all I have to do it. It will respond. It will serialize that data out to JSON and hand it back to your app. So that's a pretty simple one. The book search endpoints, plural. It's giving back an array of them this time. There's a couple in here. The first one is, again, a very simple get books. And it's just, again, replying with just a JSON payload, 3 books in an array. Simple. This second one is where we start to get a little bit more sophisticated. This is this sort of endpoint you'll see on different servers in a lot of ways. We're doing a get, but this time we're doing a book. And you see here we've got :book ID. This is where we're extracting a value out of a RESTful path. So if the server sees /book/1001, it puts 1001 into a variable called book ID and then gives it to your response to examine. So we're doing a dynamic response because we're going to run a closure. The dynamic response gets handled the request. And in there we can look at the path parameters and extract the book ID out of it and then decide which piece of JSON we're going to return. So there's a bunch of things going on. We're automatically extracting all the path parameters and all that sort of stuff. And we're also making a decision about what we're going to return, which is anything from a book through to a not found. So it's fairly simple stuff. A couple more I put in here. A cart, get cart. That one, again, is fairly simple. but where that one's a little bit different, it's another dynamic, and it's the reason because it's pulling from the cache. So Voodoo has a very simple in-memory only cache that allows you to transfer pieces of information from one query to another. So this is where this in carts are a great example of this. In the endpoint below here, put cart, what it actually does is it reads in some JSON from the request, extracts some data out of it, and then stores it in a cart in the cache. And then afterwards, if you do a get cart, you then get that information back. So it's a very crude, very simple simulation of a cart. Obviously, a real server would be a lot more going on, but for mocking and testing purposes, this works just fine. And that's the sort of thing you would use that cache for, and that's the sort of thing that you use these dynamic responses for. So I'll just run this. This is always the great part of it. I've got Voodoo running in what I call verbose mode. You can hand it a parameter that says run in verbose mode. And, okay, test is finished. When it's running in verbose mode, what it does is it gives you a list of all the endpoints that you've set up. And it also tells you when it receives a request and what that request was. So this is sort of aimed at the debugging point of view, where you've gone, oh, hell, I've typoed. Voodoo will turn around and tell you, hey, I got this request, but I didn't have anything for it. You've either typoed the Voodoo configuration or you've typoed in your app, but you'll get some feedback that says what's going on. So Voodoo will punch out a whole bunch of things, if you've malformed your JSON or if you've done whatever. There's absolutely so many different things that could go wrong at either end of this situation. So adding more and more and better reporting is obviously a thing that I'm doing as much of as I can, because the more I can tell you, the faster you can debug. So these things are critical. So that's basically how you run Voodoo, just in a simple UI test. You can actually start it, and I did it here actually just this morning. I set up a mock circuit target and created this very simple application just running with the same endpoints. So this just allows me to actually run Voodoo in the background while I'm mucking around with my app. So when I actually run the app, if I run that, sorry, so I can just run that up. Right, so that's the server, it's up. And you'll notice that it does tell you the URL that it's on and all that sort of thing. Now I can just flick back to my actual app and run that. And if it ever comes up, which sometimes it doesn't like to, there it is. Make that one go away. So that's come up, and then I can just look back at the log of the mock server and I can see, so it got the request for a config, and that was it. As I said, this app is not very sophisticated. And again, when in the scheme, I just simply handed the URL through to the app when I launched it to redirect it. So yes, you can run that in Voodoo effectively in the background while you're debugging and use it like that. As it starts and starts very fast. I am thinking about easier ways perhaps of doing that, so I'm going to be looking into things like Xcode extensions and stuff like that as to whether that can help in some way, but I don't know as yet whether any of that will pan out. So I'm going to jump back just to here, and then jump out again. As I said, stop that and stop that. Voodoo can run from a command line. So I'm going to just get rid of a bunch of stuff here. Go there. So from the command line, it looks something like this. In fact, actually, I'll just back up a couple of directories first. You would typically just build it just with that sort of command, just Swift build. That's just telling it to build a release version. You can build a debug if you want. I won't build it now because internet connections and stuff can be a bit hairy. But that builds, and that creates a command line program called Magic. It was actually going to be called Voodoo first, but I found a quirk in Xcode that wouldn't let me build a command line program called Voodoo and a library called Voodoo. I might have to report that, we'll see what happens. But for the moment, the command line program is called Magic because, well, why not? So, get back up into test files there. So, in this directory, this is kind of just a whole bunch of test data that I've been using and setting up just to sort of try out different things. I've got a bunch of templates sitting in the templates directory, and these are Mustache templates. If I go, for example, that's a very simple template that just says return an array and include these other three files, IAB1, IAB2, and IAB3. If I see what's in there, we can see that we've got the books JSON and the IAB3 files that it includes to create that response. So templates is like that. I've got, as you can see from the test configs 1, 2, and 3, the directory full of different configurations. And in fact, if I look at actually I'm thinking I might open scenario 1, might be one worth looking at. So this is what you would do if you're running from a command line, if you're dealing with an Android team or something like that. This is how they can configure things. This is a list of endpoints. These are HTTP endpoints, so you can see the first one here, we've got HTTP, we've got an API, we're saying what post to created/text. We're going to give it a 201 response, we're not going to bother with headers. The body is just going to be, response body is just going to be some text. That's it, gets pretty simple. The second response there says test config 1/get config YAML. That's just a reference to another YAML file, it just includes it. So again, this is about composing. The third one there is where it runs some JavaScript. This JavaScript is actually inline inside the YAML file. Okay, and you may notice it looks fairly similar to the closure. It gets two parameters, it gets the request and it gets the cache. And all that sort of same stuff that you have in Xcode for a closure, we have in JavaScript. You can examine all the different parts of the request and extract data out of it and return stuff and make decision making. The fourth one, again, it's just another get, just a one I was mucking around with. This just references to a JavaScript file. So if you want to keep your JavaScript responses, your dynamic responses in separate files, like .js files as opposed to embedded in the YAML, because you've got a fancy JavaScript editor that you like using, you can just do that. So let's get back to here. Go back a bit. This would be along the lines of what you would do. There's a few other parameters. There's quite a few different parameters that I've added to the Magic command line program. Always room for more. But at the minimum, you need to basically say, look, run it. Your template or your T is where your templates are for if you're using templates. If you're not, don't worry about it. You do need the config to see. Because otherwise you're starting a server that does nothing. So you've got to have some sort of configuration. It's started. It does not get faster than that. And when I was dealing with some of this, it was actually kind of fun in a way, because I was jumping around between the command line here and some YAML editors, and I'm using I don't know if you're familiar with POR, but I typically use POR, and just jumping around between these three things, just going bang and then start and stop the server, start and stop the server, change something, start and stop the server. And it was just so fast. that it was just kind of really enjoyable to do. Get config, that's all right. So I need to go to, so yeah. Get config to okay. Hang on. Why has that not? Oh, there is response. Yeah. I'm used to running Paw at a much higher resolution, so I've got these things side by side. But yeah, basically, it just responds very quickly. So that was coming out of those Mustache templates, the book template, and inserted these 3 books from other files. So I guess the takeaway from that is what I've tried to do is make this quite flexible so that you can arrange things in the configurations and the files to how your team wants to work, rather than trying to dictate to you how it should be done. All right. We'll go back to Keynote. So that's kind of the demo side of thing. I thought I'd just quickly, because you're all developers, I thought I'd quickly through some of the technologies that helped me build this thing. Because I didn't write it from the ground up. I'd be crazy to try that. Hummingbird is the first one. Hummingbird is the actual server itself. It's just a general server. It's built recently. It's built on Swift IO. It's very well built and very fast. So I wrapped Voodoo around that. Use that as my core server. JXKit gave me JavaScript core. Swift has JavaScript core for running JavaScript, if you've ever looked at that. But JavaScript core isn't available on Linux. So because, again, I want to be able to run in Docker, I want to be able to run in Linux, I needed a way to deal with that. And I found JXKit, which is basically a facade that allocates all that stuff in the background, and saved me a world of pain. Any codable? Anybody seen this one? No? One of the big problems with dealing with writing code like this is that you don't know what sort of data you're going to get. I don't know what data dictionaries, JSON structures, whatever you guys are going to set up and give me, but yeah, I've got to be able to understand it. So everything comes in as like any's, which of course I can't serialize and deserialize because any isn't codable. So any codable is a project that literally provides any with the codable option. And if you're dealing with unknown data that you've got to serialize and deserialize, that's worth looking into. GraphQL, that's quite a sizable project actually. I mainly use it to parse incoming GraphQL queries and break them down into an AST, and then I can look through them. Nimble, that's not actually in Voodoo, that's just for testing, but it's always a recommendation. YAMS is for reading the YAML files, for understanding those, so just deserializing those out. And finally, Apple's Swift Argument Parser, which if you're running a command line program, really good way to set up stuff like that. Okay, so that's it. That's where the project is currently, up on GitHub, if you want to take a look at it any time. I don't know where we're at time-wise, but I'm hoping we're okay.
Yeah, you want to take some questions?
Yeah, so any questions? There was a question down here first. I can't remember what it was.
Yes. Certainly don't remember. It was on the way. No, I don't have the slide.
All right.
Is it possible to run it in the actual, not thinking so much about the simulators, but actually on a real device? So, for example, if you're using AWS Device Farm or something like that, I want to test it on all the different iPhone sizes from the last 3 versions, blah, 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 and I want to run all my mocks for all the different screens.
Yep.
Possible to do that?
Absolutely. I did work on a project some time ago where we wanted to include a demo mode in the app that could run wirelessly. So we literally built these sorts of mock servers and embedded that inside the app. Really, you would just start it up just the same way that you do in a UI test. So just create a server, start it up, redirect to it, and things like that. So absolutely possible, absolutely can be done. The thing to watch out for, and I hit this at my last project, we originally started to do that, But then they had a massive data structure of files, of image files, because they use a lot of web views. And it increased the app size by 50 meg. So we sort of said, okay, we're not going to do that anymore. And we just ran it as a standalone server. So, but yes, absolutely can be embedded.
Good. Another question? No one else has a question?
Sorry, go for it.
Another question for you. Just thinking about, I want to make sure app config is only called once in my test. So I want to ensure that some rogue programmer hasn't written it so that every time a network request goes out, it's hitting app config again and again and again. Is it possible to do that?
So some sort of assertion.
Yeah, just at the end of the test, app config's only called once, or...
Yep. You could, I actually, honestly, I have not thought about it from an assertion point of view, as in like mocking frameworks often offer assertions. But if you put a dynamic request in there, so rather than just saying, here's your config, JSON, okay, if you said dynamic, stuck a counter or something like that in the cache, you could then hit that and say, hey, look, it's more than one, what the hell? So there's certainly, this is very new in the sense, as I said, this app's, Voodoo's only really been built over the last month. So I've got a little list of things that I want to add to it, for example. One of the ones that I'm going to add to it is a delay option, so that any point through a test, you can say delay all requests from here on by X number of seconds. Because that comes up, particularly when testing animations. That sort of stuff comes up. So GraphQL, I've added that one in, as I said. And speaking of GraphQL, you can match on, if you know GraphQL, you can match on an operation name, but you can also match on the query itself. So you can actually put in a query and say, if any incoming query kind of looks like this query, then it's a match. So there's some flexibility we're building there. Sorry?
You mean compared to SQL queries? Whether they match or not?
Yeah, GraphQL queries.
GraphQL,
Yeah.
That is not so simple.
Not simple, but it's kind of fun. Well, from a development point of view, it's kind of fun.
Just in continuation with GraphQL work you've been doing, have you considered typing your response with GraphQL? Because basically from the client, you have a request that is typed, and you can easily find out what you're supposed to serve back. So how do you, is there anything or you're thinking about doing in terms of making sure your returning types are types?
Hadn't thought of that, but it sounds like a good idea. So please go there and stick it in a request, feature request or something, because I find that when you come up with something new like this, people are thinking, oh, I can do this. Oh, can we do that? So please put them in feature requests. If you've got any ideas or questions, please put them in, because some of them will manifest, some of them may not. Okay, I'm not going to promise the world, but yeah, I'd like to look at it because GraphQL is new to me, so I'm curious as to how people use it and want to use it.
Cool. Thank you very much, Derek. We might call it there.
Yep. Thank you.